Well, now, our subject is adding up numbers. I mean, we can give an example on that. Let's say we have numbers such as 1 plus 2 plus 3, 4, 5, that. Say we have to add numbers from 1 up to 99, 100. I mean, when you're given a question like this, you can try to add them up one by one. But as you will soon discover, trying to add these numbers up one by one will take a lot of time. If not, it will be boring. And if not, you may guess it's not the only way to find a solution for this problem. So, if we want to find a solution to a large problem, to a big problem, we try to make it smaller first. I mean, we try to find a solution for a smaller version of this problem. Then we better apply the rule we find from the smaller part to the larger original part of the problem. So, if you're given a question like this, like what is the sum of numbers from 1 to 100, you better think it like this. For example, we may say, let's not add numbers from 1 to 100, but let's try to find the rule adding numbers from 1 to, for example, 10. Let's write it down like this: 1, 2, 3, 4, 5, 8, 9, 10. If we can find a solution for this smaller version, we may try to find a bigger solution later. Let's now concentrate on this. Let's focus on this part. If you like to find the numbers, find the solution of this version, some of you may want to add them up one by one, and they will find the solution. I guarantee that. But if this last number gets larger, like 10, 30, 40, or like 100 in the original version, what is for us to do? Well, I mean, if you can see this, let's think it like this. If you can see this, these numbers, this series is ascending. I mean, it's ascending like like a triangle. I mean, you can see it like this. The first one is small, short, taller, and it gets, as this triangle gets wider, as these numbers get larger, this triangle gets larger too. It's ascending. It's an ascending series. Okay. I guess, this formula, some of you may remember a formula to solve this, but the core is this: no mathematician, no scientists gets a formula from sky, or in short, he doesn't see the formula in his dream. He just has a pencil, has a sheet of paper, and he tries to think how I can find a solution for the problem at hand. It's something like that. I mean, we have to think like scientists now. We have to put ourselves in the shoes of the first mathematician who found a formula, who found a solution for this problem. We will think just like him, and I will show you how. The scientist who found the solution to this problem, it's a long story, but I am cutting it short. for I don't want to be boring, as most teachers are. However, if you try to construct this series, say from the reverse, I mean this an ascending series, let's try to write the same series in the descending format like this. Let's try it. If we can't find a solution, no problem. We may try another method, another way. No problem. We have it's like a play for us. Think of it like a play. Fun. If we find a solution, okay. If not, we may try another. If not, we may leave it out. Okay, no problem. We are trying to find something. We're playing with it. 9, 10, 9. I'm writing the series in a descending order. 8, 7. Yes. And what you will see is it goes down like this. 3, 2, 1. And it is in the descending format. I wanted to find the solution for this line, but it seems I repeated it down again, for a second time. And this series down is something like a triangle which gets small as we move right. Its height gets smaller and smaller and smaller. And what you will see here, let me correct it a bit so these pieces fit better. If you, we could try to find a solution for this problem, but we will try to find a solution together at once. I will try to sum up this series and the same series together. You may wonder why, but I see a relation like this. For example, if these numbers 1 and 10, the 1 is above and 10 is under it, if I try to add these up like this, 10 and 1 makes 11, right? Why I added them up? Because I saw something like this. As this series gets larger, this one gets smaller, and the numbers which are up and down like this, which is the second series, and the second number is under the first number, you can see a pattern like this. As these numbers get larger, this one gets smaller, and when you add the second column, you will again see 11. Why? Because this one got up and this one got down. The first one is enlarged by 1, the second one is decreased by 1. It is something like this. Here is a plus 1, here is a minus 1, and these effects are downgraded. They are opposite of each other, and the sum is 11 again. Here you can see it. 3 and 8 makes 11 again. 4 and 7 makes 11 again. If I try to sum these up all together, if I try to sum this series with itself again, I will get a sum like this. 11, right? 11, 11. And the only question is now, how many 11s do I have? Let's see it. How many 11s do I have here? This is the first 11. Second 11. It writes here as second. 3 for third. Third 11. Fourth 11. You can see it here, I guess. 10th 11. There are 10 11s here, and the sum makes 10 times 11, which is 110. 110 is the result of this series added with itself once again. So what is a single series? What is the sum of a single series? You can easily see it. We have to divide 112 by itself. We have to divide it by 3, and you get 55, which is the sum of a single series. This one or this one, doesn't matter. So I can confidently write 1, 2, 3, 4, 5, and makes 55. You can check it out. Huh? Why I went through a winding road like this? Let's see why now. I mean, you can add these numbers up to 10, no problem, with your calculator by hand or in your mind. But let's try to apply the same rule again, once again, to the numbers. Doesn't matter how large. I found a pattern here, just like the mathematician who found this rule, this formula first. Huh? I'm thinking like him now. 1, 2, 3, 4, 99, 100. If you want the solution to this problem, what will I do? As I have done, I will just write it once again in the descending order. Huh? 99, 98, 97, 2, 1. I will add the series with itself once again. And what will I see? 101, 101, 101, 101. How many 101s do I have? Let's see. Huh? It says it in the top. Huh? There's a label for it. First 101, 2, second 101, 3, third 101, and I will surely see that there are 101s here. I mean, this sum, the sum of the two series, is, when I multiply this up, it is 10,100. Huh? This is the sum of the same series with itself, added up with itself. So if I want to find the answer to this original series, if I want to find the result of it, I have to just divide it up by 2, because I repeated it 2 times, in an ascending order, then in a descending order, which gives me 5050, right? And here is your long sought formula. If I want to add numbers from 1 to n minus 1 to n, what will I do? The same rule. I will write it in a descending order from the reverse, n minus 1, 2, 1. What will we have now? Let's see. We have n plus 1. Again n plus 1, because 2 plus n minus 1 makes n plus 1. And here we have n plus 1. And to the end you can see the same pattern, n plus 1 again. Huh? How many n plus 1 do I have? First, second, n times n plus 1. Huh? The sum of this series, the sum of this series, huh? n times n plus 1. But I want the result of only single series, not the sum added up with itself again. So what will I do here? I will just divide the result n times n plus 1 by 2 to find the single one. And I can write it. Here is your long sought formula for this. Huh? You can apply any number. If n is 10, I mean if the numbers go up to 10, 10 times 10 plus 1 over 2 gives you 10 times 11 over 2, which makes 55, as we have found in the original result. You can try it yourself. But the secret is not to memorize. If you memorize the formula, you will forget it. I will forget it too. But if you know how that mathematician found it for the first time, how he thought, you will never forget this. And it will be forever yours, with no extra weight on you. It's okay for now, I guess. See you.